Children, it is a continuation of the ray diagram to show the formation of the image through the convex lens. Now let us discuss about the method of drawing the ray diagram to show the formation of image through the convex lens when the object is at between 2F1 and F1, that is between the principal focus and center of curvature. Now let us observe the ray diagram drawn by the student to show the formation of the image through the convex lens when the object is at between 2F1 and F1. Children, as usual, draw a line to represent the principal axis, and now you mark point approximately in the middle of the principal axis to represent the optic center, and it is a optic center. Both the side of the optic center mark the point F1 and to F1, F2 and to F2. Here you take 4 cm from O for F1, and again next 4 cm for 2F1. This is for the 2F1, that is for the center of curvature. Again on the other side also mark a point at a distance of 4 cm from O. Here 1, 2, 3, 4. So you draw the, here you mark the point that is for F2. Again at a distance of 4 cm mark another point that is for 2F2. Here this is F1, one principal focus, this is F2, other principal focus, and this is 2F1, that is center of curvature, and this is 2F2, other center of curvature. And at a point O, you know that O is the optic center, that is the midpoint of the lens. At that point as a center, draw a rough sketch of the lens, and if it is possible take both upper and lower portion equal. Draw a rough sketch of the lens. Here you got a lens. Now here the object is between 2F1 and F1. So you mark a object here. Draw the object, that is AB. And here where is the object? Object is between 2F1 and F1, that is between the principal focus and center of curvature. Now as usual, draw a line parallel to the principal axis to represent the ray parallel to the principal axis. It is a ray parallel to the principal axis. You know that this ray refracts, and after refraction this ray passes through the principal focus through F2. This ray after refraction passes through F2. And second ray, you take that ray passes through the optic center. You know that here the ray which is parallel to the principal axis after refraction passes through the principal focus. Next you take the ray which passes through the optic center. Here you take the ray which passes through the optic center. This is ray from the object which passes through the optic center. You know that this ray passes along the same path without bending. There is no any refraction here, and the refracted ray which passes through the principal focus and these ray meet at a point, and mark that point. Here you mark the point at which both the ray meet, and this is the position of the image. When the object is between f1 and 2f1, you got the image beyond 2f2. A dash B dash is the image, and you know that here you can observe it is an enlarged image and it is real and inverted image. You can catch this image on the screen, and it is inverted image and its size is greater than the size of the object. Now let us write the nature, position and size of the image. So you write position of the image. Position of the image. Position of the image. What is the position of the image? It is beyond 2f2. Beyond 2f2. Right? The position of the image is beyond 2f2. Beyond 2f2. And the size of the image. Here the size of the image is greater than the size of the object. It is enlarged image. Right? Size of the image. Size of the image. It is enlarged, greater than the object. Enlarged image. Greater than the or larger than the object. Image is larger than the object. Here you can observe A dash B dash is larger than AB. So size of the image is enlarged, that is larger than the object. Then you write nature. Nature of the image. What is the nature of the image? It is real and inverted image. Nature of the image. Nature of the image. What you can write? That is real and inverted image. Real and inverted image. Real and inverted image. When the object is between 2f1 and f1, you will get the image beyond 2f2 and it is a real and inverted image.